Okay, good afternoon, everyone. Can you hear me? Yeah. Okay, so I'm going to talk about what we call participatory numbers, and I'm going to provide the definition of what participatory numbers actually are in a minute. But first and foremost, I want to play a game. I hope you're keen for a game, and there's going to be a prize at stake. And these are the favorite lollies in New Zealand. Some may actually know that game. I need to know who's the smartest person in the room. Who's the smartest person in the room? No, it's going to be Kevin. Random choice. How many do you think macaroni is in the bottle? 75 macaronis in the bottle. Okay. Let's put down 75 on this card here. Okay, now I'm going to pass the bottle around, and you're going to all guess how many macaronis there are in the bottle. So try to be quick. And then we're going to compute the average afterwards of how many macaronis we have in the bottle. The bottle is here. Could you just put down the number on the piece of paper and pass the bottle to your neighbor? Does it make sense? Right? And Devald afterwards is going to compute the average value for all the guesses. Right? OK, so participatory numbers. I'm going to provide the rationale first. Why participatory numbers? And in the context of DRR. So I'm going to use a diagram we're using in different publications, which shows that DRR should be an integrated process, integrating both different forms of knowledge from the bottom up and from the top down, down to different actions from the bottom up again and the top down. But to achieve that, we need different stakeholders to actually collaborate and to talk to each other. And this is the process of integrating outsiders and insiders. And there needs to be a dialogue between these stakeholders. And most often, in DR or even development at large, we seldom have that kind of dialogue. I mean, people around the same table talking the same language about the same thing. Now, this is very true when it comes to measurements, whatever measurements it is. Measurements for vulnerability, for hazards, for impact, or whatever. Now, those two diagrams and figures and photos show the same thing, which is the measurement of land subsidence north of Manila in the Philippines. Here you've got the scientific assessment, assessment of land subsidence. And on the right-hand side, you've got a local actually measuring subsidence on a deep well using just his fingers. They are measuring the same thing with the same level of accuracy. But they can talk to each other. The guy on the right-hand side wouldn't understand the diagram on the left, and the scientist wouldn't trust that kind of measurement. But this is the same thing. So there's a problem. We can't actually integrate both quantitative measurements. Now, this is where participatory numbers chip in. And this is what we mean by participatory numbers that are quantitative data produced by those who are at the forefront of development struggles or DRR. I mean, the poor and the marginalized, who may not even know in some cases how to count or how to read. Now, they can still produce numbers, directly or indirectly. And I'm going to provide a list of different types of numbers. It's not an exhaustive list. But you can see the wide range of measurements you can come up with. First, people can come up with counts. Be it from a map or from the ground, you can count things. And you can measure that. People can compute or come up with ranks and scores using ranking techniques, scoring techniques, or proportional piling techniques, very well known from people working for NGOs, for example. People can measure directly distances, for example. Could be in miles or in kilometers, could be in time, it could be through other form of measurements. But people can do that. It's very easy. Using a meter, for example, in that particular case on a participatory map. People can actually do some spatial analysis. You don't really need a geographic information system to do that. Here on the map, you've got areas prone to landslides with the red yarn here. And these are, for example, cornfields. So you can estimate how much of the area affected by landslides actually cornfield. You can do that. You can have a proportion of that. It's quite easy. People can actually do surveys as well. And by doing surveys, I mean people designing their own questionnaires based on their own objectives, doing the surveying by themselves, and then afterwards analyzing the data by themselves and writing a report by themselves. People can do that. It's not that complicated. You can even have censuses. This is an example from the Philippines where for all the villages on the ground, you have actually records of how many people there are in the village, how many people or how many pregnant women, how many children below 5 years old. We've got that kind of information coming from the bottom up. This is very easy to do. This is counting. And you can have some more sophisticated temporal analysis using, again, proportional piling techniques, but through different periods of time. Easy to do. You can have some forms of correlations. 2 entries in a matrix, then you use proportional piling again. So you can have correlations. Easy, very easy, just using stones or bins or whatever. You can measure strengths. This is a Venn diagram for resource mapping, different colors of yarns for different strengths of connections between different resources. You can do that, very easy. Now, what's the point? OK, people can come up with all these numbers and figures and quantitative data. The point is that it makes people credible in this space for dialogue, in the sense that their local knowledge, their initiatives become tangible to outsiders. Very much the same as for participatory video or participatory mapping, when you have tangible information upon which you can overlap or you can integrate over other forms of knowledge coming from the bottom, coming from the top down, from scientists or from the government. So you can create that sort of platform for dialogue using those numbers. And numbers are always more credible for scientists and government officials than qualitative data, which you may have with a VCA matrix, for example. Now, let's verify our numbers here, our participatory numbers. Are we done with the estimation? So what's the average value for the whole group? 1,802, the average. My goodness, it's the first time it's failed. OK, so Kevin, you're already the smartest in the room. The actual number is 419. It was quite far, actually. I was very sure that the average number of the audience would be closer than Kevin's guess. But the point here is that both were very far from the actual number. And if you run that activity in other settings, most of the time, you will have the group's collective guess actually much closer than a single individual's guess, which shows how powerful people can be by working together and computing things together. Any queries? Any questions? How much time do I have? Hello? How much time do I have? No, this is not me. 5 minutes? Any queries?
So you mentioned that who counts in disaster risk reduction. So do we count the disaster risk reduction? So
say it again?
In the disaster risk reduction.
Yeah, who counts? I mean, who counts in terms of whose knowledge is important? And in that context, people's knowledge is as much important in terms of quantitative data as for outsiders. And by outsiders, I mean scientists and government officials and international organizations, NGOs, etc., etc. Any other queries? Maureen.
Okay.
I wonder why we got such a different number this time, and I wonder if it's because this audience doesn't have knowledge about how many macaronis are in the jar, whereas what you're talking about, where it works, is when communities do have some knowledge, and so they're able to make a better guess.
When I meant it's the first time it's failed, in 5 times I've run it in the past few months, it means with the same bottle of macaroni, and a larger crowd usually. It may be because I'm not sure. I mean, I struggled this morning to actually find macaronis in the supermarket here. It's not that common. So I'm not sure if people can actually estimate the size of macaroni. I would be wrong. For sure, I would have underestimated myself the number of macaronis. But the reason why it's filled is interesting, and it may be the reason, I'm not sure. Or maybe you don't like macaronis. Maybe you prefer spaghettis, I'm not sure. Yes.
Okay, my point is just it's good that we try to de-technicalize things. It's more, the local people get to understand things that are very meaningful for them.
Thanks. Any other queries? Questions? Nope. Well, thank you very much.